What is up everyone, welcome back to a brand new video. In today's video we are going to be teaching you guys how to build this insanely powerful DIY electric mini bike. This electric mini bike has a top speed of 22 miles an hour, a range of 10 miles, and with its 8 kilowatt motor, this mini bike can climb virtually any hill. All of these specs make the mini bike so much fun to ride and an absolute thrill-seeking machine. So without further ado, let's get into how we built the bike. For the frame, we're using the Azusa mini bike kit, which we got in the 6-inch version from Go-Karts USA. Azusa manufactures one of the only old school mini bikes today that is similar to the ones used in the 60s, so we had to go with one of those for the original old school mini bike look. The first thing that we did was to prime the frame, and then after that we spray painted the entire frame blue. Normally when you get it, it'll come in a standard steel piping, which just kind of looks bad, so we spray painted it blue to not only protect it, but to make it look good. The next thing we did was to take the bolt that holds the handlebars in and grease it up a little bit so that it turns in the tube nicely. We put the fork over the main body of the mini bike and then tried to slide the main bolt over into the hole that holds it into the frame. It's a really tight squeeze, but once you can get it in there a little bit, you can finish up with a hammer so that it goes all the way in. To secure the bolt firmly into the tube, put the retaining nut on the bottom and screw it all the way down using a ratchet. You can then test it out to see if you've gone too far or not far enough by turning the handlebars left and right and making sure that you like the way it feels. The tires we are using are these 6-inch tires included with the Azusa mini bike 6-inch tire kit, and it's super nice to have tires, wheels, and everything that's already compatible, and all you have to do is assemble it. There are 2 different tires, one for the front and one for the back. This smooth one is for the front, and then this knobbier one is for the back because that's where your engine or motor is going to be. And the first thing to do is to stuff the tube inside of the tire just as you would with any standard tire, and then undo that and inflate it slightly so that you'll be able to insert the hub later. It's important to pump the tire such that the tube has a little bit of shape, but not too much, so that it'll be sticking out where your hub could clip it and deflate it later on. You'll want to repeat this process for both wheels, the front and the rear, before doing anything else. These are the 6-inch wheel hub rims that are included with the Azusa mini bike kit. They fit the tires that we just pumped up perfectly as they're part of the same kit. I think that these have a really nice finish to them, and overall they just look super great on the electric mini bike. So the first thing that you're going to want to do is insert the 3 screws into the 3 holes on one of the rims, and then place this flat into one of your tires. It's important that this crescent shaped gap in the rim lines up perfectly with the inflation tube, that way it has a nice spot to sit and you don't break it. Once the first side is snugly in, you can flip over the tire and begin to insert the second side of the rim into your tire, once again making sure that that crescent shape fits with that metal piping for the tube and that you don't clip it. You can then insert the 3 nuts on the other side of those 3 bolts that you threaded through the rim and then tighten all those down using a ratchet. Once they're all tightened all the way, you can finish up pumping up the tire all the way to its max, which is around 30 psi. At this point the wheel is complete, and then you can move on to your second wheel, which is a similar process, but it's not exactly the same because you have to bolt the 72-tooth rear sprocket into the hub at the exact same time that you're bolting the wheel hub together. Just take 3 of those same extra long bolts, put them through the sprocket and then through the wheel hub. You'll have 3 of these just like the other wheel. You might need to squeeze the hub a little bit together to compress it down enough so that they'll squeeze all the way together and you can get the nut on top. Once you've got all 3 nuts secured to the corresponding bolts, you'll want to tighten those all the way down just like you did for the other wheel hub, and then you can inflate the tire. Now that you've finished both wheels, you can mount them to the frame of the mini bike. They'll sit a little something like this, and there's these steel axles and these spacers that go in between them. Simply slide this axle through the holes in the side of the fork that turns the front of the mini bike tire. Since you spray painted it, it might be a little bit hard to fit it in there because it does add a little bit of thickness. You can slowly begin to add the spacers and eventually get that wheel on. You'll definitely need a hammer because it's super hard to squeeze it all the way through there. But once it's on there, you should be able to fit it nice and securely using the other spacer. Lining that spacer up can be a little bit tricky and require a little bit of force. You might even need to bend the front fork a little bit or hammer it into place just because it's such a tight fit on the front there with the wheel and both spacers with that extra spray paint. But once you've done this, make sure the wheel spins nicely, and then you can add the nuts on both sides and secure them tightly but not too tight so that the wheel still spins. The rear assembly is a little more complicated because you also have this brake drum that goes inside of that sprocket in the rear wheel hub. So the first thing you'll need is this small spracer, then you can put on the brake drum, and then you'll see that it slides nicely on the back axle using this longer axle rod. So you can start by putting that on, putting on the medium-sized spacer. After this, you can put on the brake drum, make sure that that little fork goes in between the nut that's welded on the frame. After that, you can put on another small spacer, and then at this point, you can actually add the rear wheel with the sprocket attached to it. This part is extremely annoying and finicky, and it must have taken us at least 10 tries to get it without it falling apart when we were hammering inside the final axle. This process is a lot easier if you have two people, one to hold the wheel, one to hammer, and then once you've got the wheel actually held securely on halfway, you'll want to add the longest spacer on the other side and then hammer it all together. Once you've got the wheel on, which this process can take over an hour, it's actually super annoying, you can add the final nuts to secure the rear wheel on. Just tighten these with one wrench on one side and then a ratchet on the other side. Next, we are going to be setting up the brake assembly, which comes with the Azusa mini bike kit. It comes with one handbrake, which attaches to that disc brake in the rear wheel hub. I'm not gonna lie, the brake system on the mini bike that's included is not that good. Even having done this over 50 times, we can never get the brake assembly to work that well. We can't even get the brake to actually work when we're riding the bike, which is why we installed an electrical one later on in the video. But anyways, here is how you would construct it. There's this pin which goes through the braking mechanism right here. You push that through, pull the wire which is attached to the brake up front through that little hole, and then you can tighten that little screw right there to clamp down on the wire and hold it in place so that when you pull the brake, that little mechanism will be pulled forward and then the brake drums will expand outwards and slow down the wheel theoretically. There's an adjustment mechanism right here that we've never quite understood how it works nor gotten it to work, so if anyone has any ideas of how to get our brake to work, comment that down below because we've been struggling with it a lot and we've never gotten it to work. Before you can finish the brake though, you'll want to add this spring right in between the mechanism that pulls down and that little golden rod. This makes it so that when you pull the brake, it'll be returned to its original position. Up front, that wire that I was saying goes into this little clamp in the handle and then threaded through this little slot, which is then tightened using the screw that's already built into it. Neither of us are really pros at bikes or brakes, so if anyone has any idea how to do this better, please let us know. The next piece that we're going to mount is this seat, which is also included with the Azusa mini bike kit. It is held into place using 3 of these screws. All you have to do is put the seat on over those 2 metal pieces that go across the piping and then screw them in. There's already threads on the underside of the seat and it's a really simple process. Okay, so now we're going to be moving into the drivetrain, which was honestly the most complicated part of this build as we pretty much had to make everything ourselves for this motor to fit in. So the motor that we're using is the Flipsky 8100 130 kV motor. This is 8 kilowatts, which is insanely powerful. The motor is absolutely massive. You can't really see this just from a shot by itself. So here it is compared to a 6374 motor, which is already quite large in itself. I've never seen a brushless outrunner motor this big, so it was really impressive to see how this thing stacked up against standard e-skate motors. This motor is going to power our mini bike so much better than any other motor out there, and I was just impressed by how much it weighed, how dense it felt. It definitely feels high quality. We added some 5mm bullet connectors to the wires, that way it would fit with our ESC. We chose 5mm bullet connectors because we wanted the motor to be able to handle enough current for this massive motor. The way that we're going to be mounting the motor to the mini bike is through these 10-inch L brackets made from steel plated in zinc that we got from Home Depot. They're definitely not the greatest option out there, but they were really cheap and we figured that they'd work very well for this purpose. So this is pretty much the concept of how we wanted to mount the motor to the mini bike. It would just sit in between like that, the shaft going in between the 2 plates, and then the bottom side would be mounted to that underside on the mini bike. So what we did is we measured the distance between the holes on the threads already built into the motor, and then we sketched them out on these metal plates, and then just used a standard cordless drill and a drill bit to drill holes inside of these L brackets exactly where the motor holes would fit. The drilling process takes quite a while, but it ends up working quite well. A drill press would be the best. To mount the motors to the L brackets, we used an M5 bolt with a washer to spread out the pressure, and it actually ended up working quite well. It took a few attempts to get the bolt pattern exactly right so that the bolts were not bent at all, but eventually we were able to build two brackets that were close enough to the actual bolt pattern on the motor that worked. So it ended up being actually a cost-effective solution for bolting the motor to the mini bike, and it works quite well. If we had the proper tools or a little bit extra money on this project, I would definitely design and CNC a custom bracket for this, so that'll be an upgrade for the future, but for now it holds up really solidly. So now we're back to the bike, and as you can see, this is the place where we're planning to mount the motor. The bike already has some slots built into the bottom side right here, so that's what we're going to be using to mount the mount onto the bike. So those slots are going to allow us to adjust the tension on the motor and eventually on the chain. So what we did was to mark exactly where our L brackets are going to fit in, and then where those slots are going to line up with our L brackets. And with this, we were able to find the exact location to drill holes on the L brackets, which again was an extremely time-consuming process. Drilling through this material is extremely hard. And once we got those holes, we used M10 bolts with the corresponding washer and nut to secure the L brackets onto the bike. So the first ones that we did were the two that line up with that slot that's already in the mini bike. We just put one of the bolts through the top and then put a washer on the bottom and then put a nut over that. The washer is extremely important to disperse that pressure. That way you don't risk cracking or doing anything bad to that thin middle sheet right there. And then you'll want to do the exact same process with the second bolt. You can then tighten them up using an Allen key and a ratchet or any kind of hex nut tool. At this point, the motor is pretty securely attached to the mini bike, but we really wanted to add a third anchor to that motor mounting L bracket. So what we did was to add another slot on the bottom of the mini bike so that it holds right there. So what we did was we started by drilling one hole that went all the way through the mini bike plate and then through the L bracket. We found that that fit. We added an M10 bolt, and then once we did that, we drilled another hole about 10 millimeters away all the way through the bottom metal sheet on the mini bike. And once that drill was filled, we took the Dremel tool and then filled in the distance between them to create a slot. That way we could slide that entire double L bracket up and down to adjust the tension on the chain. Speaking of the chain, we were forced to get a custom chain after we broke the one that was included, and then we used a chain breaker to make it the proper length. You'll need to do this because this is really made for an engine, which is going to have a lot farther center distance, so you'll need a chain breaker for sure. But once you get the proper length, you can add it over and see how it aligns. With the drivetrain done, we're now going to be moving into the electronics portion of this build, which is very similar to an electric skateboard, except the way that it's controlled. So it's going to be controlled by these throttles, which are an ADC input, and we got two of these, one for the throttle and one for the brake. These are going to be hooked in to the UART port on our VESC, which is a Fockbox single that Inertian made from a long time ago. It's an extremely great VESC, but unfortunately it's discontinued, so if you're looking for a single VESC, we'd recommend just getting one from Trampa, or the Torque 6 ESC is looking like a pretty good VESC single 6 option. Anyway, so what you're going to need is a custom 6-pin JST connector to make your own connection from the VESC UART port into the two ADC controllers. So basically, just find one of these off of Amazon. It'll have all 6 wires unattached to anything, and you're really only going to need 4 of these wires. So we'll explain this in a little bit, but here's what it actually looks like physically. So the two controllers each have 3 wires. They both have a positive, a negative, and then a input wire. The positives from both controllers will connect to each other and then go into the 3.3 volt on the UART. The two negatives will connect to each other and then the negative on the UART port, and then each of the input wires will go into one of the ADCs. So your throttle will go into ADC 1, and then your brake controller will go into ADC 2. So you'll be using the 5 volt, the ground, and the ADC 1 and the ADC 2 ports on the UART port. We'll do a little schematic so you guys can see this right now. Okay, so here we have it. We have the two negatives, one from the throttle, one from the brake. Those will be soldered to each other, and then they will go to the ground on the UART port on the Fockbox. We then have the two positives. Those will also connect to each other, and then they will plug into the 3.3 volt on the UART. Then we have the input from the throttle. That will go to ADC 1 on the UART port, and then we have the input from the brake, which will go into ADC 2 on the UART port. So there you guys have it. That's the schematic. Sorry for the bad handwriting, but there it is. Next we have the battery, which is a 10S5P 360 watt-hour pack. We really only use this battery pack because we wanted to make sure the mini bike would work as a proof of concept. We're going to be upgrading this soon to a 12S 6P battery in the future. That way it'll have a lot more range and speed, but this is just for the proof of concept. To turn the bike on and off, we're going to be using a loop key mechanism. So one side will go into the VESC, one side will go into the battery, and then it'll be shorted by an XT90 that's shorted itself. It also is the anti-spark version, so that way it'll act as an anti-spark switch. So as I was saying, the battery will plug into one side of the loop key, the other side will then plug into our VESC, which has those two ADC throttles already hooked up. To turn it on, just insert that loop key, and the VESC will turn on. The anti-spark will make sure that it all runs safely and that nothing gets damaged. You'll know that it's working because the blue light on the VESC will turn on to notify you that it's all good. The 3-phase wires from the motor will then plug into the 3-phase wires that go into your VESC. The sensor wire will also plug into the sensor port on the VESC, and then you can power it on using the loop key. At this point, you can program the VESC using VESC tool, which is exactly what we did. It's pretty much the standard. You'll do your motor detection and all of that. But where it gets a little more tricky is when you do the input, because you have an ADC input from the two different throttles. So we've just auto-connected and we've just done our motor detection in FOC mode, and now we're going to set up the input. So you click the Setup Input wizard, you click Next, it'll then scan your CAN bus, we don't have one, and then you'll click ADC Input, which is a little bit different from what we're used to doing. At this point, you'll have all these green bars which come across the screen, which display your minimum and maximum voltage for your ADC throttles. So what you'll do is you'll twist your throttles up to their maximum and then let them go, and it'll show you exactly what the highest and lowest voltages are, and then you can input these where it says ADC min voltage and ADC max voltage. ADC min for 1 will be your throttle, and the ADC for 2 will be your brake. So you can set those accordingly, and then you'll go into this menu and you'll click current no reverse brake ADC2, and what this will do is when you throttle your throttle, you'll go, and when you throttle your brake, it'll apply the electronic brake with regenerative braking. We've found this to be the best option so far, considering that the brake that's mechanical doesn't really work on the mini bike. At this point, your input is set up. It's not as simple as it looks. We did have to tinker with it a little bit to get it to work, but eventually we were able to get it to work completely. The throttle might seem a little bit twitchy at first, but once you get on the bike, it'll actually be the right amount because you'll have a load on it. Now that it's working, you can mount the throttle onto the handlebar. It's a standard 22mm diameter pipe, so just make sure your throttle works with that. Then we use these clips, which are included with the Azusa mini bike kit, to align the cables along the side of the bike just to clean it up a little bit. We placed around 3 or 4 of these just so it went nicely and wouldn't snag on anything when we ride. The next thing we mounted were the foot pads, which are included with the Azusa mini bike kit. All you have to do is mount these 2 semicircular shaped clamps, put a bolt through it, put a nut through both of them, and those pedals should sit nicely and provide a place for your feet to rest when riding. You can adjust them to your liking. Another thing that we did was to shave down part of the L brackets that the motor is mounted to. These hang off a little bit and they could snag on us or hit something while riding, so we just took the Dremel and then a hacksaw to finish it off. At this point, all that was left was to mount all of the electronics, and we did this in a not so professional fastened way. We just took a ton of duct tape, wrapped up our enclosure with our battery in it so that it was nice and snugly in there. After we had the battery nice and wrapped up so that we knew it wouldn't fall out, we then duct taped this entire module right here to the underside of the piping under our seat. This is really not the best option, but we really didn't have another method because we were just trying to make sure that the mini bike would work as a proof of concept for this video. When we get our bigger 12S 6P battery, we'll make a custom enclosure made out of metal to fit much better. The ESC kind of just sits on top of the little enclosure casing. Because there's a 22mm diameter pipe, if you just slide it right under there and secure it down with some tape, it won't get in the way of anything, and it'll have easy access to connection with the battery while still being protective, as the seat will be on top of that. So once you get that all plugged in so that the circuit's complete again, you can then plug in your XT90 key, check to make sure everything works, and in our case, when we spun the throttle, the mini bike turned on and worked perfectly. For a finishing touch, we added some shred lights with shred lights bar mounts. If you don't know what shred lights are, they're these super cool lights for portable electric vehicles. They work on electric skateboards, one-wheels, bikes, and electric bikes. They're super bright. As you can see right here, this is filmed on a GoPro, which barely pick up any light, and they're just insane. They just illuminate the night ahead of us, and with the suns going down earlier this winter, it's crucial that we have that rear red light and those front headlights so that we can see and that so others can see us. You can see so far ahead with them. We will have a link down in the description below to our affiliate code for the shred lights. And there it is. That is how we built our DIY electric mini bike. This is what the finished project looked like. This DIY electric mini bike build was so much fun. Although it's finished for this video, I have to say there are so many more improvements coming along the way, and we'll definitely be releasing some update videos in the future on this bike, so if you're interested in seeing those, please make sure to subscribe to our channel down below. For any of you guys looking to build this mini bike, I'd say the most difficult parts are getting a sprocket that's compatible with both your motor and the chain that comes with it. It was really difficult to find one of those. Cutting the chain to the proper length was also very difficult. Finding a system to mount your motor to the bike is also extremely difficult. Those L brackets from Home Depot are nowhere near perfect, but they'll definitely work as a solution, and we can say that after many miles of testing, they've held up perfectly, especially on these rugged paths, so they are approved by us. Another really difficult thing is getting that battery attached to the bike. We're definitely still working on a solution for that, but right now the duct tape seems to be holding up well. A couple improvements that we have for the future. We are definitely going to be upgrading to a much larger battery. The 10S5P that we used in this video was just for a proof of concept. We're going to be getting a 12S6P pack very soon here that can output a lot more current. The cells will have a lot more sag. We can just feel that this motor isn't getting all of the power that it can get, which is pretty obvious considering that this motor is 8 kilowatts. The performance of the mini bike in its current state is still so much fun to ride, and it's really good actually. The top speed is only 22 miles an hour or so, but with that 12S battery it's going to go up about 20%. Also, the hill climbing isn't terrible. We're able to get it up most hills, and you can just feel that this bike wants to go. When you pull that throttle, it just pushes you. However, once you get going, it really isn't able to maintain that torque because the battery really can't output that much current. It'll make it up pretty much any hill out there, but it doesn't do it very quickly. Riding this bike off-road or on trails is also so much fun. We've taken it through the trails up in the mountains near us, and it's just so much fun to ride. It's definitely not its intended purpose, and the frame really doesn't absorb the shocks too well, but it's still so much fun, so we couldn't resist trying it out there. Anyways, that is it for our DIY electric mini bike. If you guys are interested in doing a build similar to this, we'll have most of the parts down in the description below so that you can find the complete parts list to it. Thank you guys so much for watching. We know this video took a long time for release, but it was a long one, so it's taken quite a while. So thank you guys so much for your patience. If you aren't already subscribed, please make sure to subscribe to us for more awesome DIY electric skateboard and electric vehicle content. It really helps us out if you guys can subscribe. So thank you guys very much for that, and thank you for watching, and we'll see you guys in the next video.